Hey, Radzion here. Today I'm going to show you how to build an interactive guitar fretboard that visualizes major and minor pentatonic scales using React and TypeScript. This step-by-step guide will walk you through creating an intuitive widget that helps guitarists learn and practice these essential scales. You can explore the live demo on pentafret.com or dive into the complete source code on GitHub. Our application allows users to explore guitar scales interactively by selecting a root note and scale type. The app then visualizes the corresponding notes across 15 frets on the fretboard. For a detailed walkthrough of the app's foundation and the core fretboard rendering implementation, check out the corresponding YouTube video in the description where we cover those topics in depth. One of the most powerful aspects of pentatonic scales in their symmetrical nature. The pattern remains identical for both major and minor scales, with only the root note position shifting. For example, compare the G major pentatonic with the E minor pentatonic scales. You'll notice the same finger patterns, just starting from different positions. This means that once you master the 5 basic pentatonic patterns, you can apply them to both major and minor scales by simply moving the patterns to different positions on the fretboard. This versatility makes pentatonic scales an incredibly efficient learning tool for guitarists, as the same finger patterns can be used to play in any key, major or minor. To enhance the learning experience, we want to highlight the relationship between major and minor pentatonic scales that share the same pattern. When a user selects either a major or minor pentatonic scale, we display a clickable subtitle that shows its relative counterpart. For example, same pattern as E minor pentatonic for G major pentatonic. Clicking this subtitle instantly switches to the related scale, allowing users to visually understand how the same pattern can be used for both scales. The getRelativePentatonic function is the core calculation engine behind this feature. For any given scale, it determines its relative counterpart by shifting the root note by 3 semitones, up when converting from minor and down for major. For instance, this is how we determine that G major and E minor share the same pattern. In our application, we represent musical notes using a zero-based numbering system. Each note is assigned a number from 0 to 11, where A is 0, A sharp or B flat is 1, B is 2, C is 3, and so forth. To present the scale patterns in an organized and visually appealing way, we create a pentatonic patterns component. This component displays a collection of essential scale shapes, each representing a different position on the fretboard. It shows a title with the current scale name, for example, G major pentatonic patterns, and renders multiple pentatonic patterns components, one for each shape in the selected scale. Each pattern is rendered using the pentatonic pattern component, which creates an interactive fretboard visualization for a specific position. The component takes a pattern index and scale type as input, calculate the note position using getPentatonic and render them on a fretboard. Root notes are highlighted to help guitarists identify key reference points while practicing. To reference a note's position on the fretboard, we need 2 pieces of information: the string number, which is 0 based from top to bottom, and the fret number, where -1 represents an open string and 0 represents the first fret. The getPentatonic pattern function builds each scale shape using a systematic approach. First, it determines the starting note by adding up the scale intervals based on the pattern index. Then it follows a specific traversal strategy starting from the lowest string, which is the 6th string, and it places 2 notes per string, working its way up to the highest string, which is the 1st string. For each new note, it calculates the fret position by either using the first note of the pattern or by adding the appropriate interval to the previous note's position. When moving to a new string, the algorithm applies a shift of 4 or 5 frets depending on the string to maintain the pattern shape. Sometimes our pattern calculation might result in negative fret positions that are less than -1, which aren't playable on guitar. In such cases, we shift the entire pattern up by an octave, which is 12 frets, to keep it in a playable range. For example, in the G minor pentatonic pattern shown, we move all notes 12 frets higher to maintain the same pattern shape in a more practical position. With these components and algorithms in place, we've created an interactive learning tool that helps guitarists visualize and practice pentatonic scales across the fretboard. The application handled the complexities of musical theory and fretboard geometry, allowing players to focus on mastering these essential patterns in any key they choose. If you enjoyed this video, please like the video and subscribe to the channel.